Now we want to use the root test to determine the convergence or divergence of the sum from n equals 1 to infinity of 2 times the nth root of n plus 1 raised to the nth power. So here we're looking at the limit as n goes to infinity of the nth root of the absolute value of 2 times the nth root of n plus 1 raised to the nth power. Again, since all of these terms are positive, we can drop our absolute values. The nth root and the nth power will cancel, and we have the limit as n goes to infinity of 2 times the nth root of n plus 1. Let's take an aside and determine what the limit as n goes to infinity of the nth root of n is. And then we can substitute that in to evaluate our limit that we began with. So we can write this as the limit as n goes to infinity of n raised to the 1 over n power. Since we have a function to a function, we want to find a way to apply a logarithm. So we're going to come in and we're going to write this as the limit as n goes to infinity of e raised to the natural log of n to the 1 over n power. This allows us to move this exponent out front. And we have the limit as n goes to infinity of e to the natural log of n divided by n. So if we come off and take another aside to evaluate the limit as n goes to infinity of the natural log of n over n, we can view this as an infinity over infinity indeterminate type. So we say that this is equal to the limit as x goes to infinity of the natural log of x over x, where we view the natural log of x and x as a function over the positive real numbers. Now, since this is an infinity over infinity, we can apply L'Hopital's rule and obtain that this equals the limit as x goes to infinity of 1 over x divided by 1, which equals 0. Now we can come in and we can look at our limit that we have expressed in green. So this equals e to the 0 power, which is 1. That is, the limit as n tends to infinity of the nth root of n is equal to 1. And again, we substituted or we evaluated the limit of natural log n over n to equal 0, and e to the 0 was equal to 1. Since the limit as n tends to infinity of n times the limit as n tends to infinity of the nth root of n equals 1, we can substitute this into the limit we have in blue, and evaluating that limit, we have a 2 times 1 plus 1, which equals 3. That is to say, the limit as n tends to infinity of the nth root of the absolute value of the terms of our series, a sub n, is equal to 3. So, by the root test, we can conclude that the sum from n equals 1 to infinity of 2 times the nth root of n plus 1 raised to the nth power diverges.